You have heard that AI is changing everything: your job, your city, your economy. But here is what nobody is talking about. AI is also about to change your electric bill, your air quality, and the energy grid that powers your country. Right now, 252 gigawatts of new natural gas power plants are being built across the United States. Enough to power every American home. Twice, not doubled, tripled, in a single year, for one reason: AI data centers. The same companies announcing net zero pledges are racing to lock up natural gas capacity at a scale this country has not seen in decades. That is not an accusation. That is what the contracts say. Let us get into it. Start with the baseline. In 2024, U.S. data centers consumed 183 terawatt-hours of electricity, roughly 4% of everything the country generates. McKinsey projects that number reaching 606 terawatt-hours by 2030. The IEA's base case, global data center consumption more than doubling to 945 terawatt-hours by 2030. And the growth is almost entirely AI-driven. IEA data shows AI-accelerated servers growing at 30% annually versus 9% for conventional hardware. A ChatGPT query uses roughly 10 times the energy of a traditional Google search. GPT-4o narrowed that gap to about 0.3 watt-hours per query, but GPT-5 swings back to between 2 and 45 watt-hours per prompt. Every time a more capable model ships, the energy math resets upward. Here is why gas is winning by default. The fundamental problem is time. Grid interconnection now takes 5 or more years on average. In PJM, the largest grid operator in the country, projects that came online in 2025 spent an average of 8 years in the queue. Natural gas deploys in 18 to 24 months. Nuclear small modular reactors are 7, 10, 12 years out. The economics of delay are punishing. An AI data center generates roughly $10 to $12 million in annual revenue per megawatt. Every year of delay is a 9-figure revenue hole per facility. When BlackRock CEO Larry Fink described data center demands over the last few years, he was describing a rational economic calculation, not a value shift. Now, what about solar and wind? Renewables are real and scaling, but they have one problem AI cannot tolerate: unpredictability. A data center running large language models cannot go offline because it is cloudy. These systems require 5 nines uptime, 99.999% availability. That is not a preference. It is a hard technical requirement. Natural gas? You flip a switch, it runs, day or night, summer or winter. That is not a trade-off these companies are making reluctantly. It is the only math that works right now. Global Energy Monitor reported that U.S. gas-fired capacity under development nearly tripled in 2025, reaching 252 gigawatts, more than one-third tied directly to data centers. Tripled. If fully built, the U.S. gas fleet grows by roughly 50%, at an estimated cost of $416 billion. Goldman Sachs estimates 60% of new data center power will come from natural gas, adding 3.3 billion cubic feet of daily demand by 2030. CleanView's 2026 report identified 46 data centers planning their own on-site gas plants, totaling 56 gigawatts, about 30% of all planned U.S. data center capacity. 90% of those projects were announced in 2025 alone. Building behind the meter bypasses the interconnection queue entirely, and in many states, sidesteps clean energy regulations. The most visible example is XAI's Colossus in Memphis. Built in 122 days, powered by up to 35 unpermitted gas turbines generating roughly 400 megawatts. The Southern Environmental Law Center sued over Clean Air Act violations. Those turbines were estimated to produce 2,000 tons of nitrogen oxide annually in a community already struggling with air quality. Speed versus compliance, made explicit. Look at the hyperscalers: Meta, Microsoft, Google, Amazon. Meta's Hyperion campus in Louisiana expanded from 2.25 gigawatts to 7.46 gigawatts through 7 additional Entergy gas plants. Microsoft partnered with Chevron for up to 5 gigawatts of gas capacity in West Texas. Google is running a 933 megawatt gas plant in Texas that could emit 4.5 million tons of CO2 annually. These are not pilot programs. These are multi-decade infrastructure commitments. and the grid is feeling it. NERS's January 2026 assessment projected summer peak demand growing by 224 gigawatts over the next 10 years, a 69% jump over the prior year's forecast. The system is changing faster than the infrastructure needed to support it. PJM's independent market monitor found that data center load accounted for $6.5 billion, 40%, of costs from a single December 2025 capacity auction. Across the last 3 auctions combined, data center-driven costs totaled $21.3 billion. The monitor filed a formal complaint with federal regulators asking whether it is just and reasonable to keep connecting loads the grid cannot reliably serve. Ordinary ratepayers are absorbing the hit. NRDC projects $163 billion in cumulative capacity costs through 2033 in PJM alone, roughly $70 per month per household. Residential rates hit 19 cents per kilowatt hour by late 2025, up 27% since 2019, projected to climb 40% more by 2030. Utility bill debt has reached $25 billion nationally. Shutoffs hit 3.5 million households in 2024. ERCOT in Texas is tracking 226 gigawatts of large load requests as of late 2025, up from 63 gigawatts in December 2024. A 270% surge. The former ERCOT chair said there is simply no way to put this much steel in the ground fast enough. Texas responded with Senate Bill 6, compelling data centers to cut consumption during emergencies. The political response is fracturing. The Trump administration has positioned itself behind rapid buildout, loosening EPA permitting, so developers can begin construction before receiving air permits. Over 300 data center bills were filed across 30-plus states in just 6 weeks of the 2026 legislative session. At least 12 states have introduced moratorium legislation. Sanders and Ocasio-Cortez introduced the AI Data Center Moratorium Act in March 2026. Senator Warner called it idiocy. Senator Fetterman declared he refuses to hand the AI lead to China. That gap is where energy policy currently lives. But step back from the politics. Because this story has ripple effects beyond electricity bills and emissions charts. Think about the workers needed to build this infrastructure. The engineers, the welders, the grid technicians. These are not jobs being automated away. These are jobs AI is literally creating demand for. Think about the communities where these plants get built. The tax revenue, the construction contracts, the supply chains activating in places that have not seen this kind of investment in decades. And the geopolitical dimension. The United States is betting that domestic energy production keeps it ahead in the global AI race. That is a strategic decision, with consequences playing out over decades. The tech industry has a counterargument worth hearing. A UCL and UNESCO study from July 2025 found that quantization could reduce AI energy demand by up to 90% for repetitive tasks without losing capability. NVIDIA claims 100,000 times efficiency improvements for inference over 10 years. Google DeepMind's cooling AI cut data center cooling energy by 40%. From 2010 to 2018, global data centers saw a 550% increase in compute, but only a 6% increase in energy use. DeepSeek's January 2025 model was reportedly trained for $5.6 million versus Meta's $60 million or more. A potential order of magnitude efficiency gain. But MIT Technology Review found its chain-of-thought reasoning used 87% more energy per response than simpler models. CEO Nadella acknowledged the core tension. As AI gets more efficient and accessible, its use will skyrocket. Efficiency gains and demand growth are racing, and demand is winning. The nuclear bet is real, but distant. Big Tech has signed over 10 gigawatts of new U.S. nuclear capacity in 2024 and 2025. But most projects will not deliver power until 2030 at the earliest. The IEA's optimistic efficiency scenario could cap data centers at 2.6% of global electricity by 2035. The IEA's base case, built on current trajectories, not hoped-for improvements, still shows consumption more than doubling by 2030. Here is the bottom line. Natural gas has won the near-term AI power race, not because it is the cheapest or cleanest option, but because it is the only one deployable fast enough to match the build speed the industry is demanding. The economic incentives are overwhelming. The federal political environment is accelerating build-out, and the efficiency gains that could theoretically bend the demand curve remain projections, not contracts. What is being locked in right now, in steel, permits, and 20-year power purchase agreements, is a gas infrastructure build-out that will shape U.S. energy and ratepayer costs for decades. The question is not whether AI needs power. It does. The question is who pays, how it gets generated, and whether efficiency gains arrive before the infrastructure is set in concrete. Those answers are being written right now in state legislatures, FERC filings, data center siting decisions, and earnings calls, where hyperscalers announce another $100 billion in capital expenditure. The AI story and the energy story are the same story. There is one principle that will tell you more about where this is going than any prediction or hype cycle. Follow the power. Literally. Because the future does not run on hope. It runs on electricity. And right now, AI is buying all of it.